Welcome to class today, geometry students, on this Monday. Hope you guys had a good 4-day weekend. And I'm not sure if you're going to be energized and ready to come back or if you're pretty depressed to be back. But either way, welcome to class and hope you did have a nice break. Well, let's always jump into it like we try to do. The good news is this will not be an extremely long lesson. It'll be above average. However, there will not be any homework tonight, so let me stop and say now, if you did not do your homework over the weekend like you were supposed to, what I need you to do then is, if you finish this video early today, go ahead and work on that and get it done, okay? That's very important. When I went to collect Tuesday night's homework due Wednesday, I did not get yours, Jake. I did let your mom know about that too, so I think she told you, but you did take your quiz, and I appreciate that, but I did not get Tuesday's homework, so maybe you could work on that. And also, any of you, if you didn't get your homework done from over the weekend, you might have a little bit of time at the end of the class period to work on that, so I hope that will be the case. Okay, we will have a test on, let's get to some announcements here real quick. There will be a test this Friday, so do understand that. We only have 2 lessons left to cover, and that's why we're not really in a hurry, a tremendous hurry this week. We're doing fine on time. You need to turn in your homework from over the weekend, so if you've not done that, go ahead and put your name on there and turn that in at this time, okay? I don't have that homework assignment in front of me, but you can always go back to the video and look it up. It'd be the video that was geometry 3.5, geometry 3.5, okay? So please turn your homework in now at this time. It is due today. Everyone is taking their quizzes, so just in a second we're going to go over our quizzes. In fact, if Mr. Harmon or the supervising teacher has not passed out your quizzes and your papers, you need to go ahead and pause the video and ask him to do that, because we are going to go over your quizzes in just a second, and you are going to need to have those out on your desk, okay? I think that's basically it. Yep, test Friday, turn in your homework, and let's go ahead and get out your quizzes, and let's go over those very quickly. Here we go. 2 lines that do not intersect but lie in the same plane. Okay, so if you missed that one, those are the correct answers. Number 2, perpendicular lines. 2 lines that intersect to form a right angle. All right. Skew lines, 2 lines that do not intersect, but they also do not lie in the same plane. All right. So 2 lines that do not intersect, but also do not lie in the same plane. Parallel planes, not lines. Parallel planes are planes that do not that do not intersect. Okay, theorem 3.1. All right angles are congruent. Okay, all right angles are congruent. Okay, moving on to number 6. If 2 lines are, hold on one second, please. Sorry about that. If 2 lines are perpendicular, then they intersect to form 4 right, and of course you could have written the words, I'm just using abbreviations. They intersect to form 4 right angles. Number 7, theorem 3.3. If 2 lines intersect to form adjacent, congruent angles, then the lines are perpendicular. Perpendicular. Number 8, theorem 3.4. If 2 sides of adjacent acute angles, are perpendicular, then the angles are complementary. All right, complementary. Now, AB equals AB is an example of the reflexive property. Now, really, it should have been the reflexive property of equality because there's an equal sign, but if you just put reflexive, I was fine with that. If AB equals CD, then CD equals AB is an example of what? This is an example of the symmetric property of equality. But if you just put symmetric, that was fine. If angle 1 equals 2 and angle 2 equals 3, then 1 equals 3. Well, this is an example of the transitive property. Transitive. Okay? So, those quizzes are definitely yours to keep. Some of you did well, some of you did not. Keep your heads up. Please keep working hard. Don't give up. And I'll be honest with you, this is a track 2 class, so we're not going super fast, and the problems are not as challenging as an advanced class, but we're still covering a lot of math, and this is not easy, and you're going to have to work hard this year. I'm proud of what you guys have done. I'm proud of what you've accomplished. We've covered a lot of math. You guys are learning a lot of geometry, and you're going to have to work hard to do well in the class, but please keep working hard. Don't get discouraged, and again, just keep working hard. Let me grab a drink of water real quick. And let's go ahead and get started. You'll need your notebooks to take some notes, your books, and paper and pen, and here we go. We're going to look today at using perpendicular and parallel lines. Using perpendicular and parallel lines, lesson 3.6, and I encourage you to write the date down. The date today is the 30th, 9/30/13, okay? Using perpendicular and parallel lines. Now, we are going to be looking today to give you some closure at 2 postulates and 2 theorems. 2 postulates and 2 theorems. Also remember, we looked at 4 ways last week, students, to prove that 2 lines are parallel. Remember? If the alternate interior angles are congruent, then the lines are parallel. If the alternate exterior angles are congruent, then the 2 lines are parallel. If the corresponding angles are congruent, then the 2 lines are parallel. And number 4, if the consecutive interior angles, or as this book calls them, the same side interior angles, are supplementary, then the 2 lines are parallel. Well, today we're going to add 2 more ways to prove that lines are parallel. So instead of having 4 ways, we're going to have 6. We're going to learn numbers 5 and 6 today. Numbers 5 and 6. Okay? So let's go ahead and let's get started. And if I go too fast, just pause the video and get caught up or back it up, whatever you need to do. And hopefully we'll do fine today. Okay, let's start off looking at postulate 10. Please copy this in your notes. I want this in your notes, so you might have to pause the video, copy it down, and then go ahead and take notes underneath. I want to give you a diagram and a picture of this, and I want you to write all of this down. If there is a line and a point that's not on that line, then there is exactly one line through the point parallel to the given line. If there is a line and a point not on that line, then there's exactly one line through that point that is parallel to the given line. Now let me give you a little bit of, let me help you try to understand what they're saying. They're saying here's a line, and then here's a point up here not on that line. We'll call this line M, and we'll call this point P. Okay? Now, if there's a line, well, we got a line right here, so we're good. And a point not on the line, okay, we got a point not on the line, we're good. Then there is exactly one line through that point parallel to the given line. So in other words, there is a line that exists, but only one. There's exactly one line that you can draw through that point that I just missed. There is exactly one line that you can draw through that point right there, point P, that is parallel to M, and we'll call it L. And now we're going to state down here, L is parallel to M. Now you take notes on this however you want to, okay? But what this postulate is basically saying is if you have a line and a point not on that line, you can draw exactly one line that not 0 and not 2, but exactly one line that is parallel, sorry for yawning, to the given line. Okay? And that's postulate 10. Postulate 10. All right, go ahead and copy down postulate number 11, please. And if you need to, pause the video. The perpendicular postulate, if there is a line and a point not on the line, then there is exactly one line through the point that is perpendicular to the given line. Let's look at this again. If there is a line, so let's draw a line. There's our line. Easy enough. If there is a line and a point not on the line, okay, fine. Here's my point not on the line. We'll call this line A, and we'll call this point B. So if there's a line, here's my line, and a point not on the line, here's my point, then there's exactly one line that will go through point B here that's perpendicular to the given line. Only one. Exactly one. Wow, it's a good line. There we go. So there we go. There is only exactly one line that passes through B that is perpendicular to line A. All right? Only one. And that's what this postulate is saying. So if you have a line and a point not on the line, there is exactly one line. That's pretty much common sense. I mean, how could you draw more than one line through that point so that it's parallel to perpendicular to A? I mean, you could draw a line like this going through B, like that, but that's still not perpendicular to A. You could draw a line like this going through B, but it's not perpendicular to A. There's only going to be one line that goes through B and is perpendicular to A. And that's what they want you to get. So if you have a line and a point not on the line, there is exactly one line that exists that is perpendicular to line A, or to the given line. All right, now let's take a look at this next thought. It's a theorem, so go ahead and copy this theorem in your notes. Theorem 311 states, if two lines are parallel to the same line, then they are parallel to each other. If two lines are parallel to the same line, then they are parallel to each other. All right? So, here's a line, here's a line, here's a line. Now, please watch this carefully. All right, here we go. Now, let's call this line A. We're going to call this line L. We're going to call this line P. Now, would you please watch this carefully, students? Look what it says. If two lines are parallel to the same line. So I'm going to state over here, A is parallel to L. And now I'm going to state over here, P is parallel to L. So I know A is parallel to L, so these two lines right here are parallel to each other. And then P is parallel to L, so P is parallel to L, okay? So if two lines are parallel to the same line, then those two lines are parallel to each other. So A is parallel to L, and P is parallel to L. So A and P are both parallel to this middle line right here. And so they're parallel to the same line. A is parallel to L, and P is parallel to L. So when two lines are parallel to the same line, then it means those two lines are parallel. So I can now state A is parallel to P. There we go. A is parallel to P. So if two lines are parallel to the same line, then they're parallel to each other. And by the way, remember earlier I told you we were going to learn two ways, numbers 5 and 6, to prove that two lines are parallel. This is one of them right here. Here it is. All right. So now we have 5 ways to prove that lines are parallel. alternate interior angle is congruent, alternate exterior angle is congruent, corresponding angle is congruent, consecutive interior angle is supplementary, and now this. If two lines are parallel to the same line, then those two lines are parallel to each other. So now you've learned a fifth way to prove that lines are parallel. And now theorem 312, please copy this down. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So go ahead and copy this in your notes. You should have your two postulates copied in your notes. You should have your two theorems copied in your notes. And now let's go ahead and take some notes on this. So let's see what happens. I've got a line like this, and a line like this, and a line like that. Good. Now, please watch this carefully. Again, I'm going to call this, I don't know, we'll call this line T. We'll call this line X. And we'll call this line A. Now, I'm going to go ahead and mark that a right angle and this a right angle. Now, look what it says. Now, watch this, students. In a plane, if two lines, here's your two lines, 1, 2, are perpendicular to the same line, this line here, then these two lines right here are parallel. These two lines here are parallel. So here's what I want you to write, okay? I'm going to write T is perpendicular to A. X is perpendicular to A. Do you see that? So T is perpendicular to A. X is perpendicular to A. So T and X, if two lines are perpendicular to the same line, T and X are perpendicular to the same line, then those two lines are parallel. So if I know that T is perpendicular to A and X is perpendicular to A, then I can state for sure that T is parallel to X. So now you just learned the last way, the sixth way, to prove that two lines are parallel. If two lines are perpendicular to the same line, then those two lines are parallel. So that's the last and the sixth way to prove that two lines are parallel. Okay? Hope this makes sense. Now let's go ahead and continue on. Now again, you're probably going to have to pause the video a lot, and that's fine. Remember, there's no homework tonight. So, and if you don't finish this video in class, you have to finish it tonight at your house, okay? You got to finish it. But go ahead and copy this down. Find the value of X that makes AB parallel to CD. Now, one thing I forgot to do is I forgot to put AB on here. So go ahead and put an A and a B and a C, sorry about that, and a D. Now, here we go. Find the value of X that makes AB, right here, parallel to CD. Now, what did we just learn in our last theorem? What did we just learn? If two lines, AB and CD, are perpendicular to the same line, then they're parallel. So all that I have to do is make this angle right here, 2x plus 2. All that I have to do is make that 90 degrees, and as soon as I make this angle right here become 90 degrees, then that means that this line here is perpendicular to this line here. So what I want is I want 2x plus 2 to equal 90, and then we'll subtract 2 from both sides. That would give me 88, and then divide by 2, and x equals 44. So what is the value of x that makes AB parallel to CD? Well, the only way AB is going to be parallel to CD is if AB is perpendicular to this line right here. That's the only way. And so if AB is perpendicular to this line and CD is perpendicular to this line, then we know for sure that AB and CD have to be parallel. So with that in mind, then I want this angle right here to be 90 degrees. So 2x plus 2 equals 90. Subtract 2 from both sides and then divide by 2, and you get 44. Okay, let's continue on. Use the information in the diagram to explain why A is parallel to C. Now, go ahead and copy this in your notes. Use the information in the diagram to explain why A is parallel to C. Now, come on, guys, think about this. Look, do you see how there's one arrow here and one arrow here? Do you see that? You should see that. Well, that means what? That means A is parallel to B. Now let's come over here. Do you see how there's 2 arrows here and 2 arrows here? Sure you do. Well, what does that mean? Well, that means that B is parallel to C. So think about this. Remember the theorem. Explain why we know that A, way over here, is parallel to C, way over here. How do we know that? Well, let's think this through, guys. Look, if A is parallel to B and B is parallel to C, do you not see what's going on here? A is parallel to B and C is parallel to B. So we have 2 lines, lines A and C, and they're both parallel to the same line. Well, guys, that sounds like a theorem to me. Right here it is. If 2 lines are what? Parallel to the same line, then they are parallel to each other. Those 2 lines are parallel. So, this is pretty simple. If A is parallel to B and C is parallel to B, they're both parallel to the same line, then I can definitely state that A is parallel to C. And of course, the directions say to explain why. I just explained why. You can word it however you want to. But A and C are parallel to the same line, B. And anytime 2 lines are parallel to the same line, then those 2 lines have to be parallel. All right, let's continue on. Find the value of x so that D is parallel to E. Well, again, this is going to be called a kind of a redundant problem. We've already done one like this. We're going to go ahead and do it again. Look, if D is parallel to E, then that means, and there's 90 degrees right here, that means this line right here is perpendicular to D, and it should also be perpendicular to E because they're parallel. So here's what I need to do. If this whole angle right here were 90 degrees, think about it. If 5x plus 10 let's try something that's not going to work. If this whole angle right here, 5x plus 10, is 90 degrees, if that was 90 degrees, that would mean then that E is perpendicular to this line here, which is good because remember, if D, we're going to call this line A right here. If D is perpendicular to A and E is perpendicular to A, then D and E have to be parallel. They have to be. So really, all that I need is to take 5x plus 10 and set it equal to 90 to make sure this angle right here equals 90. Subtract 10 from both sides, so 5x equals 80. And now divide by 5. And x equals 16. So whenever you put 16 in for x, this whole angle right here becomes 90. And as soon as this whole angle becomes 90, that means E is perpendicular to this line here, which we're calling A. So E is perpendicular to A, D is perpendicular to A. So D and E have to be parallel. They have to be. Okay? I hope you've listened well. Hope you've worked hard. Hope I've not put you to sleep. Sorry for the couple yawns along the way. A little tired myself. Please work hard. Be ready to do some homework tomorrow in class. So when you come in class tomorrow, you work on homework the whole hour. And then on Wednesday, we'll cover one more lesson and then start the review sheet coming up Thursday and Friday. Okay? All right. Hope you guys have a great rest of the day, and we'll talk to you tomorrow.